What is object storage? It's a piece of information, a text document, a picture, a song, a movie, or even a DNA sequence, combined with a description and stored in a single namespace with a unique key. The description, the metadata, replaces the directories used to organize and describe data in a file system. You could organize pictures from an event with several folders, starting with a folder for 2010, and then a folder for September, and then a folder for New Hampshire. Putting all your pictures in the New Hampshire folder will let you find them later, but the series of folders is not much of a description. Or, you store each picture as an object with metadata that can be very detailed. You could have a complete date and time, a location with map coordinates, the compression format, the photographer, and one or more keywords describing the event. Object data is unstructured, and it can seem counterintuitive to organize data without a structure. Structure can identify a piece of data, but it walls off different parts of the data, and not everyone makes structure the same way, so it's difficult to search across directories and find things with common attributes. Metadata does a better job with flexible detail that can feed a later search, and unstructured object data is all in one place with no walls blocking a wide search. How are objects stored? An object could go to a disk or RAID array, a cluster with replication, or a cluster with erasure coding. Anything really. Object does not mean replication, and object does not mean erasure coding, but many users think it does. Users also think that object is safe data on cheap hardware. It's really combining data and metadata and storing in a single namespace with a unique key, even though most users just think it's cheap storage that grows. Object, combined with the right protection, is inexpensive storage that grows. Replication and erasure coding are two ways to protect data. Replication simply writes more than one copy to hard drives on more than one server. The servers and drives should have similar performance so that a read can use any of the copies transparently. It's great for small objects because the object isn't split up into smaller pieces when it's copied. It's not good for efficiency, so it needs more raw disk capacity. Erasure coding breaks up objects into pieces, then calculates some number of parity pieces and writes each piece to a different server. It's great for larger objects, it's good for efficiency, and it could have good performance from parallel I/O. Object storage combined with replication is safe, but may be pricey. Object storage combined with erasure coding is safe and inexpensive. Wait a minute. How are multiple servers inexpensive and safe compared to RAID? Don't multiple servers cost more money? Not with commodity parts at the right scale. Spreading the data across multiple servers allows using commodity parts that have lower cost. SATA drives instead of SAS, single data path instead of dual data paths, basic servers instead of complicated servers with failover, Ethernet fabric instead of Fibre Channel or InfiniBand. Commodity parts have a higher chance of failure, but a failure does not take down a protected cluster. If the user needs lots of space anyway, then the large number of disks and servers makes erasure coding cheaper than a high availability RAID. Both replication and erasure coding offer a safety choice. Choose how many errors the system will tolerate before the data loss. High availability RAID with SAS has 2 servers for redundancy, no more than 2 because SAS only has 2 data paths, and more than 1 to handle a single server failure. The RAID type determines how many disk failures high availability RAID can handle. RAID 5 can handle 1 disk failure, RAID 6 can handle 2 disk failures. Replication is more flexible. It could have 3 copies, 4 copies, or more. Only 1 copy has to survive to prevent data loss, so replication could tolerate losing multiple disks and servers. Erasure coding is also flexible. It could be 8 data pieces and 2 parity pieces, also known as 8 plus 2, which means it could lose 2 disks or servers without losing data. It could be 8 plus 4, which means it could lose 4 disks, or something completely different like 20 plus 6. Replication can be as safe as erasure coding, but the price of safety is higher with replication. Don't forget, though, that object storage can be on anything because it's abstracted from hardware. What object storage does Seagate have? Lustre is object storage, so the ClusterStor L300 is object storage. It's a specialized application protecting data with high availability components in RAID, creating POSIX on a scale-out storage cluster. So, a better question is, what general purpose object storage does Seagate have? The answers are hardware platforms, the G200 plus OpenStack, and the A200. A hardware platform is for someone that already has a particular application in mind and needs hardware to run it. We recommend the controller, a JBOD or embedded server depending on the application, and type of disk. The enclosure and disks are SATA because replication and erasure coding don't need dual data paths. Someone who wants to run an open source application could use a Seagate hardware platform. The G200 is for someone who wants object, object and file and block, a small starting capacity, and enterprise features. How does the G200 with Spectrum Scale support object? IBM wrote storage provider drivers for OpenStack. Why does the G200 have a smaller starting capacity than reference architectures? The 5U84 is a big enclosure with lots of drives, and both replication and erasure coding need multiple enclosures to protect data. Multiple 5U84 enclosures means the starting capacity would be several petabytes. The G200 protects data with just one enclosure, so the starting capacity is hundreds of terabytes. Since the G200 needs high availability RAID to protect data, it uses SAS enclosures and drives, and dual embedded servers with failover. This does make the cost per terabyte higher, but you get good features and fit. The A200 uses object storage with erasure coding and works with ClusterStor hierarchical storage management software to archive a high-performance file system. Who could use the A200 for object? If data is only at one site, if it must have fast throughput, and if the application uses a limited S3 command set, then the A200 could be a good fit. Object is where scale-out storage is going, and Seagate is ready.